Hey there, it's the quartic formula here. I'm sorry for not uploading recently. I've been out of the country for most of the summer, so I haven't exactly had the environment nor time to record math videos. But I'm back, so yeah. Okay, so today we're actually going to be covering one of my favorite integrals. And that integral is the integral of e to the negative x squared. Now, if you look at this, you might say, okay, well, that's just integration by substitution. And that would be wrong. If you look at it again, you might say, okay, well, maybe integration by parts will work. And that's wrong. Partial fractions makes no sense here. So in terms of integration techniques, you're sort of at a loss. And actually, you can find out that this integral is not elementary. So it cannot be expressed in terms of finite operations, so it can be expressed in terms of finite amounts of additions, subtractions, nor in terms of trigonometric functions that we know of and that we're comfortable with. So we would say, okay, well, how do I integrate this then? Well, you have numerical methods, right? So you could obviously just trapezoid rule it, or Simpson's rule, or approximate it in a myriad of ways. Or we could be a little more clever and get an antiderivative, because this isn't asking for a different integral, it's asking for an antiderivative. So for an antiderivative, you can be a little more clever, and we can use the Taylor series and integrate the Taylor series. So let's go ahead and do this. So we know that the Taylor series for e to the x is equal to 1 plus x squared over 2 factorial plus x to the third over 3 factorial, and so on, giving us 0 infinity of x to the n over n factorial. Right, so these are equal. Now, we also know that with Taylor series, if we have composition of functions, we can just compose the composed functions. So we have f of g of x, for example. We can just compose g of x into our Taylor series for x. So in this case, g of x would be negative x squared. So we can put that into the Taylor series and get e to negative x squared is equal to negative x squared. Oh, let me put that in the sum first. That would be important, wouldn't it? Negative x squared to n over n factorial. Now, this turns into negative 1 the n x to the 2n over n factorial, because you have negative 1 times x squared. So it's not negative x to the 2n, it's negative 1 to the n times x to the 2n, because a times b to the n is equal to a to the n times b to the n. Great. So we have this here, and obviously I put the sum in front of it again. So this is our series representation of e to negative x squared. Well, that's great. We have a series representation of the function we want to integrate. We haven't actually integrated anything yet. We haven't found the antiderivative. So let's go ahead and do that. So we have e to the negative, well, we have the integral of e to negative x squared, which is equal to the series, n equals 0, infinity of negative 1, the n x to the 2n over n factorial. Now, this series has infinite radius of convergence because it's a form of e to the negative, it's a form of e to the x, so no weird continuity stuff we have to worry about here. Now, we know that the integral of the sum is equal to the sum of the integrals. So we can sort of swap these and integrate this inside term. So we know that anything to the n is going to be constants. We only want to concern ourselves with terms with x's in them, right? So the only non-constant here is x to the 2n. Now, you may look at x to 2n and say, okay, well, great, how do I integrate that with respect to x? There's n, right? Let's do it with n. Remember, when we expand the series out, that's just going to be a constant. So really, we can just use the reverse power rule. So 2n, the integral of this with respect to x is equal to 2n plus 1 over 2n plus 1. Over 2n plus 1. Right? And this is a constant, so we can move that out of the integral. So we're just concerned with x to the 2n. So we integrate this, we get, with respect to x of course, we get that is equal to sum from equals 0 to infinity of negative 1 to the n, that remains, because that's constant, x to the 2n plus 1 over n factorial times 2n plus 1. And because we want a general antiderivative, we add a constant term. So, this is the integral of e to the negative x squared, and you may say, okay, well, that's great, what does that even mean? Well, and it's a lot to get into, but this curve looks like this. Not to be confused with 1 over x squared plus 1, it's a different curve. But this actually looks a lot like the standard distribution, and in fact, you can see the multiple of it, it is. So, it's used a lot in statistics, and in fact, we can define a scalar multiple of this antiderivative, of the antiderivative where c is equal to 0. We call it the error function. But yeah, this is a very interesting integral, I think. It's one of my favorites. And this method of taking a series with a known continuous function, like sine over x, or cosine, sorry, not sine over x, sine of x, or cosine of x, and plugging in terms, yields this sort of yields this output. So thank you for watching, and please give feedback in the comments. Bye.